Well, I'll tell you, just setting up the camera and getting this thing in view, my goodness, is it stunning. The lighting, and it's just beautiful. So welcome to the Composite ARF or CARF F100 project. This is one that's been in the making for a while, and it's time to get started on this beautiful masterpiece. So we are still waiting on the landing gear from CARF and a couple other little scale bits, but that doesn't stop us from getting going on this, and we are expecting those items possibly in the week coming. So for you guys in the video, it'll be pretty much seamless. What we need to do is, there's a lot of parts and pieces that we haven't unpacked yet inside the fuselage. So we're going to start disassembling this plane, splitting the fuselage again. The split is right here, and we're going to start unpacking all the little bits and bytes to kind of get everything laid out, get everything organized, and get going on this project. All right, we did a little bit of rearranging here in the shop. We took the F15 from up there, put it over there to get ready in about a month to get it delivered. We took the F14 where Nez was sleeping all the time, put it up on the rack, and now we've got access to all 4 tables, and we kind of need it because this thing is big. It's deceiving how big it actually is from pictures, but the wings are huge, all the surfaces are huge. But we've got all of our parts laid out, and that's kind of the key here, is getting all of our stuff laid out and kind of taking a look at everything. So one of the things I struggle with on a project like this, when there's no like manual and really haven't ever played around with one of these F100s, seen one, you know, whatever, is just wrapping my head around everything. So I've spent a couple hours just looking through everything, checking out some online resources. There are quite a few online resources. So Elad Fish, as an example, he's one of the CARF reps. He's got some details on there. Of course, there's some RC Universe details as well. But yeah, so we'll take a look through everything. We've got the fuselage still sitting on the stand, but everything's emptied out. So typical CARF inside, lots of nice looking construction techniques. And we've got everything laid out here on our various workbenches. So lots of stuff going on here. Now we're using our normal setup, which of course is jetty stuff. So we've got our central box. We're using a 310 in this aircraft. So like normal, when we use a 310 in this situation, we will have 3 batteries on this aircraft. So we're going to have 3 4-cell 4,000 milliamp batteries. 2 go to the central box and power other things, but 2 go to the central box, and the central box drops the voltage down to 8.4 volts. That's why we're using the 300 series. Then there'll be another battery which runs the turbine. So we'll fit other things in there as needed, like we've got our lighting system which needs to be fit in, we've got our landing gear which needs to be powered, so we'll deal with all that stuff. We're using a Cortex, of course. We're using jetty equipment all around, so we've got our RC switch, M speed sensor, 2 Rec 7s. So it's actually a pretty straightforward setup, and we will set this plane up. We'll wire it up for a 900 as well too. We're using a Chikoi 240 in this aircraft, so we want to keep it fairly light. Most of the guys that are flying this plane, they're using like a, you know, depends on the brand, of course, but like a 250, 260 type thing. So the 240 is, it's going to be on the lighter end of things. It is a big plane. It's kind of deceiving here, of course, with the 15 in the background, but it's a big plane. It really is. Now, one of the things that we're thinking about doing is using a fuel bladder in this aircraft instead of our fuel tank. Now this fuel tank is 5 liters. I believe this is the standard CARF Hawk fuel tank, which is 5 liters. Beautiful fuel tank. If we have to use it, we have to use it. It's fine. But there is a very nice mounting point for the fuel tank. And if we take that out, we do have a nice amount of room to put a fuel bag in there as well too. So gonna take a look at that and see what we can do. Now, one of the things we would need access to is the filler port, which comes out the top. Now our midpoint on the tank is in kind of this area right here. So as long as we could have a port of some sort in this area here, filling would be not so bad. So now one of the biggest struggles looking through all of this is mounting the drop tank. So we've got a set of pylons for the drop tanks. which are these guys here. So the ones that kind of have the funky curve to them are the ones that are for the drop tank. So they kind of go like this type thing. So this is definitely the biggest challenge, of course. It's not like a Skymaster kit where everything comes pre-done for you. And yeah, there's lots of stuff to figure out with this guy. So anyways, lots of things to do. So one of the struggles I have with where we're at in this project is we don't have all the parts, right? So as I've mentioned at the very beginning of this video, we're waiting for CARF to ship us the gear and stuff, which is fine. We're waiting on, well, we need to figure out servos, which we have figured out. So our servo layout here is as follows. So we've got rudder, we're using 599, elevator 599, flaps 9930s, these are all MKS servos, and ailerons 599. For the doors, we are using 1220 high voltage. For steering, 1220 high voltage. So pretty much a standard servo layout. The reason we're using 9930s on the flaps is if a brushless servo ever fails, it generally will lock in place. So I guess to give you a number, 9 times out of 10, not that we've had that many servos fail, but if a brushless servo fails, it is stuck. You have to almost take pliers and move the thing. It's pretty nuts. So if we're using the 9930 on this plane, the flap servo linkage comes through here, goes through there. We are able to get a mechanical lock with this setup, which is great. And then if the flap was to ever fail, we want that servo just to let go and the flap to be free moving. You don't want to be failed in this position and be stuck in full flap. So that's kind of the reasoning behind it. So that is where we're at. We've got everything laid out. Don't know where I'm starting yet, but I'm probably going to split this fuselage as a first step. And we need to check and see what servos I have in stock and what we need to order. All right, fuselage split is actually quite simple. If you did need to split this fuselage for transportation, you can access all of the screws through the hatch here. So we're gonna slide this guy back a little bit because the fuselage is gonna be balanced towards the nose before we get too crazy here. That's better. The other thing too is like when I think about some of the CARF planes that I've worked on, like the L39 as an example, the L39 is great kit, love it. It's built very light, just like most of the CARF aircrafts, but this one is quite stiff. I know that might sound like a weird thing, but we've got nice carbon reinforcement in the top, but just in general, the plane is quite stiff, not super flexible, which I like. I think it's a nice thing. You don't have to be super careful, you know, if you're holding it somewhere. Yeah, very, very nicely built. This thing still comes in under 25 kilograms if you build it nice and light. So, all right, we do have some locating pins on here as well. I'm just checking the front. So yeah, so that's basically it. Very, very nice. Actually, no, there isn't a bolt in the center one. So getting this apart, you basically have 5 bolts right there, all with the stainless steel locating pins that you can see. So that's actually where the bolts thread into. And you'd have access to that no problem. So definitely interesting. We're not going to set it up like that. We'll probably put a connector in here anyways, just in case. I like to have that now just in case, but we're not designing it where there's like quick connects where this thing needs to come apart. So, but that is the back end out of the aircraft. All right, it's pretty stinking cool how minimalist this aircraft is, just to help with weight. So pulled the tape off holding the elevator cover or horizontal stab cover off. So just marked it out. It's held on with 2 screws on the leading edge, which is cool. And that's what the pocket looks like. So nice structure here. We've got a big carbon plate, making sure that this is exactly equal. Big hardware holding all this stuff together, which is great. So yeah, very impressive. But this is the kind of stuff that we'll take apart and make sure we Loctite everything, even though that's glued in place. We've got a sacrificial block here, which is, I think, for shipping. So helps to make sure that this doesn't over travel like that. So actually maybe this one stays in place, I don't know. Anyways, but that's pretty neat stuff. So I think we're going to try and install a chute mechanism in this aircraft as well too. So that's going to be an interesting challenge. So, but this is where the chute mechanism goes. It's kind of a unique chute system, as if you watch the BVM F100 build series, the chute goes in here. There's like a spring-loaded piece that pushes it out, and then the cable actually goes on the exterior of the aircraft and runs up here to this area and connects inside the fuselage. So you can see the difference there between this side and this side. So that's what the panels are for there. I think on the full scale one is to prevent the cable for the chute from rubbing through the skin maybe. So anyways, very cool stuff, very cool stuff. So I think I've kind of got my starting point here. I think we're going to start with our tail end of the aircraft with just getting servos sorted out. So going to work on that. I think I've got some in stock, but we'll kind of do whatever we can at this point, which is kind of one of the downsides. All right, in preparation here to get things rolling with the installation, I'm currently burning in our servos, cycling our servos as we call them. Many commenters always say that this is an absolute insane thing to do, but we do it. So we run our servos through 990 cycles before they get installed in the aircraft. To do that, we use a jetty box, and this is what we do. So it's already preset up here, so I'm gonna hit yes. So we do 990 cycles. The distance is 500, which is the full amount of travel, and the velocity or speed is 30. And that's what we do. So we just leave this be. It takes about 15 minutes per servo. Once the servo is done, we put a check mark on it, and that is something that we do to every single servo that gets installed here in the shop. So it's normal practice for us. Some people think it's crazy and they've never had a problem with a servo, which is fine. We've installed thousands of servos in aircraft, and by doing this, we've eliminated probably 10 to 12 servos that had issues during this process. So it's good practice in my mind, and it also helps to identify possible failures before they're in an aircraft and happen in the aircraft. So that's why we do it, and that's what we're doing to the servos for the F100. Now with that, we need to get our jetty devices updated. So our two Rec 7s here, one's going to be a clone, one's going to be a primary. The clone will just be set aside for now, but the primary we need to be updated. We're going to also update the central box, so all of those devices get updated. Then we can create a model in the radio and start programming our servos and surfaces. All right, and just so for reference here, if we take our tank, now this tank doesn't have its clunk in it or anything like that, and we're not going to include the mount that this sits in, but just for reference, this tank weighs 317 grams, so that is about 3/4 of a pound. With all the other stuff, let's just say a pound. I think that's fair. Another 100 grams for all the, you know, the fittings and the clunk and all that stuff, the bits and bytes. Now we've also got this guy, which needs its carbon rods. So we'll take the carbon rods and cancel out the mount from the other one. But this tank is 123 grams for that. So we basically save about half a pound on the aircraft just by going to a fuel bladder, if that works. Now I'll tuck this in so you guys can see what it looks like inside the fuselage. Now we'll just lay it in the actual existing tank holder because the dimensions are very similar. And there it is. So we do have a lot of room available to make that bladder work. So that's good. Now if we get rid of the tank holder, the white supportive tank holder, we could run verticals up from that former work, and those verticals would be the mounts for our fuel containment device. We'd obviously want to raise it up a little bit so it's not touching that carbon. So as I mentioned, the only downside is we need to figure out access to that top filler port and be able to pull that guy up. So if I get that lined up with the top of the fuselage here, we are roughly right in this area right here. So some sort of access panel in this area would be ideal. So I'm going to do some more thinking on that. Going to leave the bag in there so we can constantly take a look at it, but that's kind of what we're looking at. Even this area right here, if we could get that cut out, that would be stellar. All right, so we're just getting to our last servos here to burn in. So we've got one 1220 left and we got a 599. We've got our model all created in the radio, and we've got the basic layout here. So we're using, I think, 15 of these ports on the central box. So a 300 series is stellar for this. So I think I'm going to start off with the rudder. All right, so definitely at a bit of a crossroads here with getting this set up for lights on the back. So I took our rods out. Now there's no access through the holes, they stop. Took our actual rudder surface off, and that doesn't make a difference because it's all completely enclosed in there. I have a feeling that this opening goes all the way to here, which is fine. You know, just thinking about this, maybe we could run it down there, but I don't think so because, well, you know what? There's actually a lot of room there. That might make perfect sense. You know what? That might be exactly it. And then our hole is here, our tube is there, so we're about a finger width back from the tube. So that means that our lights would be sitting right there. Interesting. Okay. Okay. Well, that's good. Because yeah, if I reach in here and just check the structure, so if I squish this down and try and feel the structure where things are, we've got a former that we can see through here. That goes right across. And then if I keep going, it looks like there's a bunch of stuff right there. Now it looks like it's pretty much wide open, except right here. So that's another issue as well too. So this structure that we can see in there, which isn't terrible because we could get through there, but there's a splitter piece right here. So we would have a struggle getting from here to here through that support. Yeah, dang. So I think actually doing a small hole in these guys and just coming down this surface right here might actually be the absolute best way to do that without absolutely destroying the structure inside there. So now what that also means is that we can put our rudder servo in and we can do all this stuff afterwards. We don't have to pre-run our wires through here. Now if we're using the power box wire, that'll be nice and skinny, so we can tuck that against the inner part here, cover it with some material, and you'll never even know it's there. So all right, so rudder surface is done. Pretty straightforward. You do have to move the slot down towards the base of the rudder, so that's a bit of a kind of a crappy thing, because it would be, I would actually rather not have a slot here or have it properly spaced. Anyways, not a big deal. We got that moved down. We're using an MKS carbon arm, these guys right here. And all the CARF hardware, so we've got a 3mm rod, we've got a piece of carbon over top, that needs to be trimmed. We've got our CARF clevis, which is aluminum, which is awesome. One little thing that I do here is I just put some rubberized CA over top of the little E-clip that fits on that. Sprayed some kicker on it. I do put CA on my threads here. I don't use the lock nuts. And the carbon rod is also glued to the 3mm rod. So we make sure that on this end we always bottom out the 3mm rod, so that's bottomed all the way out to the plastic. Then we do our adjustments on that side. So this is all good. We're centered on the surface itself, and kind of our limiting factor for travel is when you go this direction, if you go past that, you're going to have the arm hitting the actual surface itself. It was buzzing because it was on the table. But we basically have the max travel available right there just before it's going to hit on the carbon rod. So that is awesome. As far as the actual movement goes, I don't know what it is. I've just maxed it out, but we could check here. I think this is set to 27 right now because that's what we were shooting for. Yeah, we've got more than that. We've got about 32 right now. So if it needs to, we could dial it down, but that's not a bad thing. So anyways, that portion is done. Obviously, we still have to run our lights. I've decided that I'm not going to pre-run the wire here. I'm just going to wait and possibly just use the wire from the Unilight kit. But it's fairly straightforward to pull this guy off and allow us access down there. Nice and solid surface. And those 599 servos from MKS are awesome. Now I did go in here and I did reduce our travel in the rudder channel. So our dual rates are going to be quite high, but our rudder channel itself is dropped down. So there's no possible way with our max positive limit drop down that any mixes or anything will allow you to go beyond that. Because if you go beyond that, the rod might hit, you might damage something. So that's why on some of the surfaces like this, when you can get mechanical damage, I like to limit our max throw. All right, so in the rear fuselage bag here, we've got these little things, these little L-bend things. I don't really know what they're for because we've got 4 of these guys for the nozzle. So that's cool. Maybe for pipe or something, I think maybe. And there's a bunch of little rivets in here. That probably is pipe. We've got 2 little spacer blocks. So I'm going to make the guess that this is for pipe stuff. That guess is purely based on my experience. And then we've got all this stuff. And I'm assuming all of this stuff is, or has to do with, the rear control rods. So we've got these big 4mm threaded pieces, and we've got some big honking clevises here. These are steel clevises, and it looks like this probably would get glued into a carbon rod. Again, I'm just making some assumptions here, and it looks like this probably goes through like this and then gets, of course, clipped on like that. So a lot of assumptions going on here. And then there's some other random bolts. Not really sure what all that's for. So we do have a wing package, which is nice. Drop tank with pylon set. I don't really know what that's for. Obviously it's for the drop tanks, but when I look online, the mounting has nothing to do with that. Stab mounting screws, that probably goes back with this stuff. And then we've got a main fuselage package here. So yeah, good times, probably for gear doors and stuff. So I'm not much of a whiner, but that's pretty frustrating when you don't even have any pictures, nothing. Maybe there is such a thing, but we haven't gotten anything and nothing came with the plane. So I'm just going to continue trucking on and see what we can figure out with this stuff. So here's some carbon rods. I'm assuming, like I said, that these probably get glued in there because it's a good fit. And this is probably the control rods for that back end. So, all right, guys. So a little update for you on the clevises that we received. So it's been a couple days since we recorded that last bit of the video, and these are in fact not the correct parts for this aircraft. So I did reach out to CARF, spoke with CARF and dealt with it. So they've got the actual ball joints which are supposed to be used en route to me, which is good. So that's all solved. It's just purely just a packing issue. So if you happen to get those clevises, don't use them because they're not right. So we got a cool little piece of tech here, and it is pretty darn slick. And I'm glad we got this because it helps us move forward in this aircraft. So we got the new Chikoi LGC 25H here at the shop. So as far as gear controllers go, this thing looks and feels like a piece of jewelry. It is amazing. So nice setup here. It looks pretty slick. A couple of the initial things I noticed is we've got some, it looks like 3mm screw holes in the back. So you could template this out and mount this to the underside of a board. We could also make a 3D plate for this and have this mount to the plate screw down. Of course, you could just use double-sided tape as well too. Pretty slick unit. I've just played around with it a little bit, and initially I was like, yeah, how do you program this thing? And it's got a little, I think that's called a USB-C plug-in, but it's like an iPhone. So you just swipe down, there we go. So you got manual operation here, open all doors, retract gear, extend gear, user manual, QR code, all this stuff here. And then we enter the setup. So if we go into the setup, you basically have swipe up and down to get into the radio setup and stuff. And then you've got each of the screens. So when you swipe left to right, you're moving between the items which everybody's familiar with. So all the different setup sequences and items. And then we've got, if we go down or up, you're basically getting into each of those setup screens, right? So motor setup example, and exits preset. So there we go. So pretty cool little unit. That's what we're going to be using on the F100. Very, very nice. I also like that it comes with the MR XT30 connectors, I think they're called. All right, so because we have the gear controller now in stock, we can install our gear doors. So at least we can make a couple steps forward in this process. We are still waiting on the landing gear, but we're going to be using this controller with the gear doors. So big thumbs up on having something to do. All right, so we'll take a basic look here at putting one of these door servos in before we actually put it in the airframe. So we'll go through the programming process here. One of the important considerations with the gear doors are when they are closed, if this is the linkage for the gear door, you want it to be mechanically locked. So opens, the servo's holding it open. When it's closed, you want it to be mechanically locked. So that's one of the considerations to think about. But I'll just show you kind of what to do here. So we're going to go into the setup and we swipe. So we've got the sequencer setup. I don't think it's going to be in there. Servo position setup. So that's where we're going to be. So servo endpoints number 1, number 2. So there we go. So right now, I always do the nose is number 1, and then left will be number 2, right will be number 3. So that's the sequence to it. So we just go opened. So right now we're in the open position. We can go plus whatever we want. So if mechanically locked, we are, can't hold that button down, you got to push it. So if mechanically locked, we are in line with the servo. I'm just making this up right now, so just to show you guys an example. So if that's mechanically locked, we'll keep it there, and then we'll go to our, oh, that was the open position. So closed position there. You guys get the idea though. And you can go all the way to a minus 100, 120 usually, something like that. So anyways, so that might be mechanically locked. And then when the door opens, which we're backwards here, but that would be the open position there. So that's basically how you do it. And then, I don't know if it saved what we did there. Yes, it did. So if we go 125 is the max, swipe up. So yes, it is saving automatically no matter where you put that in. So that is good. And then on the actual servo outputs, you've got 8 door outputs, which is awesome. Obviously, you can use those for other items as well too. So what I'll do on some planes is if we have landing gear lights as an example, you could sequence all of that stuff to the gear controller. So, and actually on this plane, we may end up doing that. So You've got the Unilight kit's going to come with some drop-down lights. Now those servos can be operated from the Unilight controller, but we could also operate them from the gear controller and have the that tied in as well too. So what I've done sometimes is like our gear channel, you can use one of those door channels that will go to your light programmer or whatever controller you're using. So when you go gear down, those lights will turn on. When you go gear up, they turn off. But it is nice to use like a lighting channel as well too, to have a master control so you can turn everything off. So you can set up a condition where you would have it has to have lights on and gear down for it to operate. So there's lots of different ways to do it, but very functional controller, very programmable, very cool to be able to see one of these things in person. All right, so one of the really nice things about most of the CARF gear doors is they're installed with the little piano wire pins, which are great. So in this case, we need to drill out our mount here to a 3mm mount, which works out perfect because we can just take the door off, get it over here, and drill it out. And like normal with pretty much all the CARF kits, this is a norm. You want to be using their hardware. If you were to use like a standard small servo screw, like a RTL fastener servo screw, you're going to find that they don't fit the holes properly. So you always want to make sure you're using the CARF supplied hardware because they fit the holes very well. So this is what we're going to screw that nose servo in with. And we've got F100 parts starting to roll on in. So I'm assuming based on the weight of this box or lack of weight in this box that it is going to be a cockpit, which I'm pretty sure it is. Yes, sure looks like it. So I'm going to pull the parts out of here and we will take a look at this probably gorgeous cockpit. All right, so nice and straightforward it looks like. So it looks like we've got one cockpit, one seat, and some parts there for, I suspect, mounting it. Oh yeah, very nice. Nice and light, wow. All right, so there is the main tub. Nice that it's all assembled already. It's built out of like light ply as well, so very, very light. Got some sort of scale handle thing. That's cool. I'm not super familiar with the F100, and I'm not a F100 connoisseur like some folks, so I don't really know what a lot of the little details are of the plane. All right, what do we got here? Oh, this is the front area. The dash, so this is all fiberglass. Very nice, all pre-painted, pre-done. And I'm excited to see the seat here. All right, wow. Beautiful. That is gorgeous. Very nice. Looks like it's all 3D printed, I would assume. That's cool. The little box that this stuff came in, it said ABS light, so I'm assuming it's printed in ABS material. And then it looks like we've got a decent mounting system here as well with little buttons and stuff. So it should be quite straightforward to get this in and out. And I'm assuming with those buttons, this piece will just drop in place and then should be fairly easy to remove because we're going to have to pop that cockpit. I don't know if I have to pop the cockpit in and out or at least the front panel here, but that's going to have to come out to change the batteries, which are going to be on the front tray there. So, all right, so nose door is installed here. So the actual limits on the servo haven't been programmed yet because we kind of just had them roughly put in place when I did the programmer. But the important thing with this is that when we are in this position right there, so where everything is in a straight line, the door is nice and tight, we're mechanically locked, so the servo doesn't need to hold any force when this is closed, and all it's doing is holding this position. It's the arm and everything, the geometry here, which holds it all together. And then when it's open, no problem, and this limit here, we still need to adjust in the controller. So that is essentially how those doors are set up. The main doors are basically done the exact same way. So our servos are going to go in this area right here. I believe we have to use a little bit longer arm. So that nose door, I used a 20 millimeter center to center arm. And then on these guys for the mains, we're going to use a 25 or a 1-inch horn center to center. So our hole for our system is right there. So again, we're going to do pretty much the same thing. So the arm's going to come down like this, open up, and then when this closes like that, you're going to have the servo arm come up like this, and it's going to be directly across from where that linkage sits. So it's going to be sticking up like that is the plan. And then we could also run those servo arms like this as well too. So there's a couple different ways to do it. One of the things to think about is we want to be aware of the turbine, which is going to be sitting right, actually the turbine's sitting back there. So we do have really this area is pretty much wide open. So as long as you're getting that lock when this is closed, that's the important thing. On the other note here, this is a great example of what I was talking about with these pins. So when you want to take these doors out, so we're going to drill those holes out to 3 millimeters. Super easy to pop those guys out and drill that hole out. Makes it much easier. All right, so gear doors are done on the mains and the nose. So here they are in action. You can see the movement of the arms. So I just went to the gear up position. So it's going to be, again, a little bit delayed because we don't have our landing gear installed. But there we go. So they're nice and locked as well too. So the servo's not really doing much except holding the position. So that is fabulous. Nice big step accomplished. It actually feels good to get some of this stuff done. Of course, while we wait for our parts. So yeah, so that's good stuff. That's one nice thing about this aircraft so far is putting the surfaces together that we've done has been quite easy. It's a nice thing to be able to get all the surfaces installed, programmed and everything like that. And then we can start to get into the nuts and bolts as our parts start to arrive. So gear doors, done. And we got some fun orders that arrived today. So we got our afterburner light setup. Now this is going to be cool because I haven't used these ones before. These are the low profile afterburner lights. Looks like there's 3 in there. That's interesting. Obviously we'll take a look at that. We've got different diameters there. So we've got the lighting kit as well too. So this is the F100 lighting bundle, which is wonderful. We've got probably the afterburner controller. We've got our nose gear, very nice. Looks like we've got mains as well too, much bigger size than the ones we had on the BVM F100. And then of course we got the electron retracts. Now these are I think the NGs, the big ones, and they will use a 3-cell LiPo, which makes all of this a little bit easier. Yes. So yes, we've got the big NGs here. So those are the monster ones. Now, we are using the Chikoi gear controller. We're not going to be using the electron hub box thing. So anyways, that is, this right here. So we're not going to be using the smart box. You can see the difference too. Like the smart box is nice, but it's also a lot larger than the Chikoi controller with the built-in screen. So this is nice. I'm a little sad that Electron kind of went this way, because if you look at this combination, now you don't need to leave the data screen connected, but if you were, that's a lot of extra stuff. And then if you don't leave the data screen connected, you need to leave availability for this plug to go into the box. So you need access to this box. Not like you're ever really adjusting anything, but it is something to consider on some planes. All right, so here's our landing gear up close and personal here. So the nose is a little bit different on the F100. So with the way things are set up here, you've got a steering system. So you could either do this as a cable pull, or you could hook a rod up to there. So we'll see how we're gonna do that. So when this extends, obviously the pin interlocks with the actuator, and that's how you operate it. Landing gear is beautiful. They did an amazing job on this, so very nice. Nice and scale landing gear. The mains are huge, like 4-inch or bigger, maybe 5-inch, 6-inch, I don't know what size those are, but they're big. And nice electric brakes, which is awesome. So very nice setup. That's great. The afterburners are also pretty cool here too. So if we take a look at those, there's 3 different sizes. So we have 2 oranges and we've got a blue, which is very cool. The other thing I like is these are 12 volt automatically, which is great. So if you look at this, the inside diameter is 131, inside diameter is 141, inside diameter 151. So you're going to have an orange, the blue, and an orange, which is going to be a pretty cool setup because what happens is if the pipe is just shy of the turkey feathers here, basically you're going to have all that glow coming out of that area. So we'll paint the inside of this white with BVM ceramic heat shield paint, and that'll just absolutely make this back end glow. So great touch on this aircraft. That is going to be stunning. Now this kit came with the actuators already set up. So this is the Actuonics actuators that we're using, or that came with the kit. So the ball joint is going to mount on the actual air brake side. And then on the fuselage, we're going to use the little metal brackets. They've kept all the hardware here. So this is what the metal bracket looks like. That metal bracket is going to mount to the pieces of wood. And we may have another piece of wood that this mounts to depending on position. So all the hardware is there, pretty straightforward. And then our actual air brake for now is on the slider here. So you can see there, they work in tandem. Nice and simple. Because of the Y cable and all that, it's only using 1 channel as well too, which is awesome, and should be a fairly straightforward install. All right, so the way I'm working this out is I'm taking my pieces of wood and I am going to just CA the bracket onto the piece of wood. Now the kit also includes some big Phillips heads. That's what you're going to use to screw these plates in there. But for now, just for positioning, I'm going to get these guys just mocked up in place. So we're going to take a little bit of medium CA, get that around the hole there, and we'll get that installed in place. Now those may need to be positioned a little bit different, but that's okay. We'll just get those mocked up for now. All right, so if you take a look there, we've got everything mocked up. Now those actuators are just resting in place. Now we've got them extended just a little bit. If you look at the base of the actuators, we've got them extended by about 5 to maybe 7 millimeters. And that's going to give us a little bit of extra play for travel. But what I'm going to do now is take some medium CA and just get those base plates tacked into place, and then we can see how they operate. All right, air brake is all tacked in place. So what we'll do now is we'll just check the operation of it. And if we're happy, then we'll go back and we will high sol around the perimeter of our blocks and everything there and get everything fastened down. But the point of spot gluing it is just to make sure everything works. So let's take a look from the outside. So we won't extend it all the way because it will hit our stand if we do. So we'll just go about halfway, a little further. Nice. And then all the way off. Wicked. That's awesome. Beautiful. All right, guys, and that is going to end video number 1 in the assembly series of the CARF Models F100. The build so far is going awesome. Obviously, it's a little bit scattered, but we're making some progress. So next video, I don't know where we're going to continue on with, but we're just going to continue on with getting stuff done. So I'd just like to take a minute and thank channel members. Thank you guys for being channel members. If you're watching this and you're curious what a channel member is, feel free to check out the links down below to channel membership. It is a paid thing, but our channel members get to see our videos early before they go live on YouTube. So usually they get to see them sometimes 2 days, sometimes a week to 2 weeks early. So thank you, channel members, for what you do. Thanks, guys, for watching, and we'll see you in the next video. I'm very excited to see everybody at Turbines and Tumbleweeds in Sweetwater, Texas, October 2nd to October 5th, 2025. See you there.